So when you're doing problems, what's the first thing you should actually try to do? Look and see what they ask you for, those type of things. So what are they asking? So area, okay. Of a what? Area of what? A rectangle. Okay, that's important because that's something you should know. What's the formula for area of a rectangle? You're probably going to need it. Not trick questions. These are really the simple ones you learned in like probably elementary school at some point with the area. How do you find the area of a rectangle? Length times width. Very good. These are the easy questions. Okay, so somehow I have to figure out and change that into something that we can actually do some math or some calculations and stuff with. I know I have 2,400 feet of fence, right? So that would technically be my perimeter, right? And how do I find perimeter of a rectangle? Correct. Okay. What does he say in the problem that's going to probably change one of those two equations? Huh? We're missing one of the sides because we don't need one along the river, right? All right, so we're just going to do, we'll do 1L plus 2W. So one length and two widths. All right. Drawing a picture is always a nice thing. Kind of helps a little bit figure out what you're doing. When you're doing word problems, the book always does them in X's and Y's, and a lot of people do them in X's and Y's. My personal suggestion to you is never use X's and Y's. Use something that makes sense for the problem. Okay? Because what will end up happening is you use the X and the Y's, and then at the end, when you have the X and the Y's, you have to try to figure out what they meant. So it's an extra step. So, like in this problem, we're talking about length and width. Use L and W. Like it doesn't matter what letters we use. You can use any letters. None of the math actually changes. So use something that makes sense. So in this case, we're going to use L and W. Okay. So I need to somehow take this and turn this into an algebra type problem or some kind of an equation that I can do some calculus on. Okay. So we've got the perimeter. So I know this one is 2,400 equals L plus 2W. So why don't we solve this one for L? Because that's kind of the simplest one, right? So I have 2,400 minus 2W equals L. Because now I can take my area equation and do 2,400 minus 2W times W. Hey, look, I have a polynomial now. So we're looking for the maximum area, right? Okay, so let's take this and turn this into when we're looking for maximum area or maximums or minimums, we're looking for what thing do we use to find that? What have we been doing all along in calculus? Derivative. We're going to find the derivative of it. So find me the derivative of area. Now, how do we use the first derivative to find a minimum or a maximum? Finding zeros. Okay, so find me my zero this one. What other values could come into play? So we have our zeros. That's the first derivative one. We also have the endpoints of my original function. Remember, because these don't go on forever. Like there's values that make sense for length and width. Okay. So like, what's the biggest the width could possibly be? Right. But in this problem right here? Like when we're looking at this right here, what's the biggest possible width there could be? If I put 2400 there, it'd be too big, right? Because it's 2 times W. So 1200 would be the maximum I could have as a width, right? So my width is going to be between 0 and 1200. So those two values also are ones that I have to check. Because remember, when we're looking at the graph, those could possibly, the endpoints are also ones we need to look at. So we look for our zeros, we look for values that don't exist. In this case, there's nothing that doesn't exist, so we don't have to worry about that. But we also have to look at the endpoints. So I've got 3 values here for my width. So I've got a width of 600, a width of 0, and a width of 1200. So my length of the width of 0 would be 2400. That one would be 0. And the 600 one would be what? Length would be what? 1200. Because put 600 into that, I get 1200. So we just need to find my area of each of those. Second two are easy. So those don't work. What's 600 times 1200? 720,000. So that is my maximum. Those are the dimensions that are going to give me my maximum. So steps, you need to get an equation. So you need to look at the problem, figure out what they're asking you to do, use the equations that you know or are given. You're not always going to have to find the equations. And most of these problems are all known as optimization problems. So you're always going to be looking for the minimums or maximum values in some way or form. So you're typically going to be looking for your first derivatives. You're going to be looking for those critical numbers to test them. So it's exactly what we were doing before. They're just now in application problems that you'd actually do. Well, I don't think anybody's ever going to build a fence along the river, but the next one actually is useful. All right. So anything in business, the goal is to make the stuff for as little money as possible and sell it for the highest amount of money as possible. That's the goal because that maximizes your profit. So when you're trying to make cans and stuff like that, or box or whatever it happens to be, to hold materials or holds liquids, you want to be able to make that can or container have the biggest possible volume inside for the least amount of material used. Does that make sense? Okay, so what do you need for this problem?
Volume of the can.
Okay, so the volume of the can they gave you is 1 liter, right? So the volume is for a can is, or for a cylinder, is pi r squared times height. And I'm going to tell you 1 liter is 1,000 cubic centimeters. If you don't, not everybody does. All right, so you've got that. What else do we need? I think I've heard it. Why do we need surface area? That's where the metal is going to be. Good. All right, so surface area of a cylinder is 2 times pi r squared plus r times height. Hold on. 2 pi r height. Circumference times height. Okay. Make me my equation. I'll give you a nice little picture of it. Somehow you got to use those 2 equations to make 1 equation.
No, that was all that.
Try to find an equation. Again, I've never said like, "Oh my God, you're wrong, you're horrible." It's like, so just try.
Oh, you spoke for R. Okay. You can do that.
That's fine. That is the equation. Now find your derivative of it. That doesn't go there because that's area. So area is going to be cubic centimeters squared. Well, we want volume, we want area, right? So somehow I have to change, and I've got 2 letters. So somehow I have to solve for one of the letters at volume to plug into the area. So 2 letters, solve for 1. We're never wrong. Like you do it, that is mathematically correct. Square root.
solve this one. Solve for one left.
Whenever you have, like, so we're trying to minimize the metal, right? So we're trying to minimize area. So this is the equation I want to use for my derivative. I got two letters. I got R and H. I can only do one letter. So somehow I got to get rid of one of the letters and replace it with something else. So use the volume equation to find one of those letters. H. Always use the letter that's by itself, basically. Makes your life a little bit easier. Less steps to do. So like in the last one, I solved for L because that didn't have it. So I wasn't gonna have to do any division after that point. This one, we have R and H. The H, I just have to do one step. The R, I'd have to divide and then do the square root of it. And then I have to deal with square roots and why I add more hassle to yourself. So now I have my area in terms of R. So I have 2 pi r squared plus 2 pi r times 1,000 over pi r squared. I only have one letter now. Now, we could definitely clean this up some before we do our derivative. The pi's cancel out, one of the r's cancels out, and 2 times 1,000 is 2,000. All right, so find me my critical numbers. What do you have to do first before you can find my critical numbers? So find me my derivative. my derivative?
4 pi r plus 2,000 over r squared.
Isn't it minus? Yeah, it's minus. Because it's our -1. All right. We need to find our critical numbers now, right? So we need to find out when this is 0. The way it's set up right now is not going to be that easy to find the critical numbers. So we need to make it one fraction. And I would see if you can factor anything out of the top. All right. So where does this equal? Where's the critical numbers? Huh? Okay. Okay. So really, so I have the top because the 400 doesn't mean anything, right? Like there's nothing I can do with the 4. So this one is going to end up being, so r equals the cubed root of 500 over pi. So any other critical numbers? The r squared. If that equals 0, the problem doesn't exist, right? So R0 is another critical number. Okay, so I've got 2 critical numbers now. Got that one, and I've got that one. All right, so I need to find the minimum amount, correct? So I've got this split, right? I've got to figure out, first of all, I got to figure out, is that going to give me a minimum? So we don't know if that's a minimum or a maximum right now, right? We just know it's a value, one of my critical numbers. So we've got 0 and that, which I just typed into the calculator to get a, like, and as a decimal, is 5.42. Approximately. So I just need to pick a number somewhere over here and somewhere over here to see if it's what it's doing, right? If that's a minimum, what should it be doing? This side should be positive, or no, sorry, this side should be negative and that side should be positive, right? It's decreasing to that point and increasing out of that point, correct? Okay, so if I plug in, let's say 1, as long as it's between 0 and the 5.42, that's all we care about. And I don't need to care about anything over here because my radius can't be less than 0. Okay, so if I plug in 1, what do I get? Well, pi minus 500, that's definitely going to be negative, right? So that's negative. If I plug in, say, 6, let's 6 cubed. Actually, let's just make it easier. Let's plug in on 10. It doesn't make a difference which number I plug in, right? 10 cubed is going to be 1,000, right? So obviously that's going to be positive. Okay, so we know this is a minimum. Awesome. I can't plug 0 into the problem, so that's not going to be the value. So I know that's going to give me the absolute minimum value. So my radius is that, and my so we can go back to my original volume problem to find my height, or actually we can use this equation right here. So height equals 1,000 times pi over pi squared. Now, I will always say that when you're doing a realistic style problem, give a realistic style answer. No engineer is going to want that for the height. They're going to want an actual value. So we'll say that the machines can't do anything less than 2 decimal places. So we can use the 5.42 for that. So we have 1,000 divided by pi. And we get 10.84. So my radius is 5.42 and my height is 10.84 centimeters. And I get 1,000.4 cubic centimeters. So pretty close to that. 8.35 would actually give me almost exactly 1,000. So there you go. That's what you'd have to do. Hmm. So a little while ago, this was all over the news. That an asteroid could hit the Earth. Okay. So it's like a 1 in 2,000 chance that I was actually going to hit, which honestly is a pretty high chance in the grand scheme of space. So the question is that typically things in orbit in elliptical patterns, right? Yeah. And what we really want to find out is what's the distance from Earth to that elliptical path. Okay, because if it's too close, what ends up happening is that the Earth's gravity will grab it and pull it in, or adjust the trajectory for the next path around. All right, so we're looking for how close is the Earth to the path, right? Now, I'm not going to make you figure this out for an asteroid because there's a lot, the equations are astronomical, literally. However, the same concept exists for this problem. So here is a simple parabola. Find the point on this curve that's the closest to 1/4. You guys can ask me for any equations you want. I will tell you formulas. Oh, I'll give you a picture. Just imagine that's an ellipse that actually goes around the other side. We just don't really need the other side of the ellipse. Do you have everything you need, or do you need something? Or are you guys still trying to figure out what you need?
Yes.
No hints. You have to tell me which function or formula you're going to need. What am I looking for? I'm looking for X and Y. Correct. Yeah. Looking for distance, right? what am I minimizing? I'm minimizing distance. Yeah, don't need the distance. Now, I will give you one little hint to make your life a little easier. Minimizing the square distance is the exact same as minimizing the distance. So it saves you having to do the square root problem. Okay? So you can work with this equation instead. Both. Obviously, if you don't have to deal with the change with the square root, life's a little easier. Oh, if you raise the problem, distance space, usually a bunch. Probably do the pre-calculus. Pythagorean theorem runs as a distance equation. Probably the distance equation when you're doing sine, cosine, when you're doing the identity rules. That's how you get it. That's how you get it. Cosine squared plus sine squared equals 1. Same problem that you had before. We have 2 letters. You get rid of 1. In this case, either one is actually just as easy. It doesn't make it any more complicated. And the problem actually comes out pretty nice with these numbers at the end. Unlike the last one. Oh, it is. There is 2 equations on the board.
Oh.
Oh, okay. So you don't pull it out. Just leave it.
That one's going to be more messy trying to do it out. It's going to be helpful. I want to see this one.
Then the only one left. Thank you. Four back, either one. Either top or three blind. I can't put that in. Now, see, this would be a valid use of systems of equations in the tutoring test or interview that I did the other day. I think most of you went that direction.
That makes sense? Which part? So that's my y, right? That's the function, correct? The derivative chain rule. So we have to do the derivative of the inside, which is just y, because that's going to be 1/2 times 2y, which is just y. And then I bring that down in front because it's 2 and it's subtract 1, so there's the 1 left. So that's how you get the 2y with that left inside. The derivative of y minus 4 is just 1. So it's literally just bring down the 2 and subtract. So that's how you get the derivative. That makes sense or no? Yes? Okay. Now, 2y times 1/2 y squared gives you y to the third. 2y times negative 1 is negative 2y. Plus 2y, those cancel out. 2 times negative 4 is negative 8. So the equal is there. You're looking for your critical numbers. In this case, there's only 1, 2, because it's the cubed root of 8. And then we plug that back into the original problem. I get x equals 2. Yes. Huh? Oh. It actually should come out to the same way. Hold on. If you did it as, so instead of this way, you did y equals a square root of 2x. That? Okay, it's a little messier. But, so, hold on. This becomes x minus 1 squared plus square root of 2x minus 4 squared. So this one just becomes 2x minus 1 plus that's the square root of 2x. So I've got square root of 2 over 2 square root of x. So square root of 1 over 2x. Actually, let's leave it as the way I had it. That's what you got for the derivative. So I get 2x minus 2 plus that 2 cancels with that 2, so I don't have to worry about that. Square root of 2 times square root of 2 is going to be, or square root of 2 times the square root of 2 is going to be 2. Square root of x over square root of x is nothing. Because I have square root of 2 times the square root of 2 times the square root of x over the square root of x. When I multiply that times that. So that becomes 2 and those cancel out. So that's 2. And then that times 4 gives me negative 4 over the square root of x. So those will cancel out. And then left with that. which should give me 2. It does, because you can, so I have 2x minus 4 square root of 2 over square root of x equals 0. So I have negative 4 square root of 2 equals 2x square root of x. So I've got, oh, take care of the negative sign because I did the other, moved it over the other side. So I have 4 side would be 16 square root of 32 equals 2x to the 3 halves. Oh, I should divide by 2 first. So I've got square root of 8 equals that. So that's 2 to the 3 halves equals x to the 3 halves, so x equals 2. There's probably an easier way to do that, but that was just the way I was thinking as I was going. But x still equals 2. But this goes to show you what was the very first thing I told you at the beginning when you were doing these problems. Pick a letter that's by itself. The x was kind of by itself. There's nothing else. You just divide by 2 and you're done. That's actually a lot easier than doing the square root. Like, don't put extra stuff in there that you don't necessarily want to deal with. So, but they both come out to be the same. All right. I give you an easier one now. I promise it's actually easier. I'm not just saying that. And no, you do not have to add in tariffs for the TV. All right. What's the biggest rebate you should give, or the biggest discount? So the two things you need to figure out, I'll give you. You need to figure out the price. And you need to figure out the revenue. So the price is how much did each TV cost? And the revenue is how much they're bringing in based on how many TVs they sold. So this one right here is T times whatever your PFT is. So find me the price of the TV.
Well, that will tell you how much they're making right now. Yeah. For revenue. That's not gonna tell you the price of the TV, the max for principal. But if you did find the revenue, there's that. Step in the right direction. It will be a linear relationship, I will tell you that, but it's not. It is gonna be a linear relationship. So your price does not have any squares or anything else. So sometimes it's easier to actually try some numbers. Okay, so how would you figure out the price? If I'm just gonna say it. Um, if I discounted it by $10, how many TVs would I sell? 220. Okay, and how much would the price? 340. Okay. So start looking like that. Like, how would you set up an equation to do that?
So what's my equation? And you can start off with, if you want, just making it the y minus y1 equals m times x minus x1. You don't have to necessarily go directly to that. What's your slope? How'd you get 70,000? Oh, don't do that yet. That we're going to do here. How much is it going down by? How much is it going up by? So my slope is almost. No, you were closer the first time. Negative 10 over 20. Slope's going, it's a negative slope. So I have y minus 350 equals negative 1/2 times x minus 100. So I end up getting 450 minus 1/2 t. So then my revenue is the number of TVs times 450 minus 1/2 t. Or yes. Oh, he was right. It was 200. Sorry, I did the 1/2 times it. The 1/2 times the 200 is still going to give you 100. So it still comes up to be 450. I mentally did that one out because I knew I wanted the 100. Good catch. All right. That's my revenue. I want to maximize revenue. So find me my derivative and my critical number. TVs. Yeah. Like I said, always pick something that makes sense for the problem. We're selling TVs, so I use T. But yes, typically T is used for time, which would make really sense with the way you're reading it. So I did a capital T instead of the lowercase t. So what's my critical number? Huh? 415? Oh, 150. $450, right? You said? Okay. I thought you said 150, and I'm like, that doesn't sound right. $450. Okay. So 450 TVs. So that means my price, I'm selling how many more TVs than I was selling? 250 of them? I was selling 200, now I'm selling 450, so 250. What's 250 divided by 20? Because they want to know the maximum. So the question was the biggest rebate. So I'm selling 450 minus 200. So I'm selling 250 more TVs, and I sell 20 more every time I do it. So it's 12.5 rebates or $125 because each rebate was $10. So that's the thing at the end. You get your answer. It's like, oh, okay, 450. Yep, good. That wasn't what the question was asking. You have to go back and look at the question and say, okay, what's the question asking me to do? So yes, you've maximized the revenue. You found 450 TVs is the maximum revenue. That's perfect. Great. Now the question was asking, well, how much of the rebate do I got to put in? We have to put $125 rebate. So we cut the price of the TV from $350 to $225, and that makes me the most amount of money. All right, last one. Anybody going into electrical engineering? Yeah, you'll like this one. Or you'll hate this one. This is one of the two things. The nice thing is this one, I'm giving you the equation. So you are going to, you need to find me P of R, the derivative of R. So the only thing, so this and that, those two are the variable. Everything else you treat as constants. Okay? So the E squared, the little r, those are constants. Find me my derivative. So derivative of the top, which is just e squared. Because remember, that's a constant, so the variable, if it was like 2x, it would be just 2. So that's where the e squared comes from, times the bottom. Minus the top times the derivative of the bottom. Derivative of that would be 1. So the chain rule is just bringing down the 2. Divided by the bottom squared. Yes or no? Okay. Simplify it. So you're gonna have to FOIL this out. So FOIL, not the thing, FOIL. No. What? The big R and the little r are two different values. Oh, you could cancel out one of them. Yeah. Because you've got that there. So you can cancel out that one, and so we still have r plus r to the third on the bottom. You could do that. That would save you some foiling time. Good catch. If all the values have to be positive, we can't have negative voltage, we can't have negative resistance. If all the values are going to be positive, when does this equal 0? What's the only piece here that could possibly be 0? So we're looking at this. So e squared is constant, right? So that can't be 0. R plus R, if I said they're all positive, could that ever be 0? No, because you can't add two positive numbers and get a 0. So the only piece that could possibly be 0 is that. So how does that actually become 0? Huh? Right, if R equals R. So big R has to equal little r. That's the only way there's 0. So if R equals R, I go back to my original problem. Little r. Wait. I did screw that up. Just r. So that becomes 4r squared. So that's the maximum power. Huh?
Big R.
Yes. These are plus, so we're adding them, not subtracting them there.
Oh, okay.
We go back to the original problem.
Yeah,
Yeah, so the derivative is there, which is what we wanted, right? But now we have to go back to the original problem to determine the maximum power. So in essence, that's, so you know how you short a battery? Like you just stick like a wire over it, it shorts out. This isn't actually shorting it. The ohms, the actual resistance would be a little higher than just like a copper wire, but it would actually give you the maximum amount of power out of that battery under a very short amount of time. But the thing we just did, there's no numbers in this. Okay, there's absolutely no numbers in this. So everything we just did will work for any battery. Okay, so that basically you just found an actual like law of electrical engineering. That's how that, and actually that's how most of the stuff is done. So that's why in physics, if you do the algebra-based physics and the calculus-based physics, the calculus-based physics is actually easier because the calculus allows you to find the stuff, where the algebra-based physics you have to memorize it all. So it's a little bit easier. All right. So next week we're going to do basically a bunch of review. So I'm going to go over the curve sketch, and we're going to go over all the different pieces and stuff that you can find. And then we'll do the review for the test on Thursday, and then your test is the following Tuesday. Yes. Yes. This is still chapter 4. Chapter 5 is integration. So we start to go backwards. Oh,